Okay, so good day everyone. Our lesson for today is all about the three laws of motion. Now we are done last meeting with the speed, velocity, and acceleration. And for now, we will proceed to the three laws of motion. So in our previous sections, you learned how to describe motion in terms of distance, time, velocity, and acceleration. Okay, so the relationship between forces and a change of motion is obvious in everyday situation. When a car, bus, or plane starts moving, you feel a force on your back. Likewise, you feel a force on the bottoms of your feet when an elevator starts moving upward. On the other hand, you seem to be forced toward the dashboard if a car stops quickly, and it feels as if the floor pulls away from your feet when an elevator drops rapidly. These examples all involve patterns between the forces and motion, patterns that can be quantified, conceptualized, and used to answer questions about why things move or stand still. These patterns are the subjects of the Newton's three laws of motion. Now, we will be tackle about the first law of motion, the Newton's first law of motion. Now, the Newton's first law of motion is also known as the law of inertia, and it is very similar to one of the Galileo's findings about motion. Recall that Galileo used the term inertia to describe the tendency of an object to resist changes in motion. Newton's first law describes this tendency more directly. Now, in modern terms, the first law of motion, okay, states that every object retains its state of rest or its state of uniform straight line motion unless acted upon by an unbalanced force. So what do we mean by this? So this means that an object at rest will remain at rest unless it is put into motion by an unbalanced force. That is, the net force must be greater than zero. Likewise, an object moving with uniform straight line motion will retain that motion unless a net force causes it to speed up, slow down, or change its direction of travel. Thus, Newton's first law describes the tendency of an object to resist any change in its state of motion. Okay, so think of a Newton's first law of motion when you ride standing in the aisle of a bus. Okay, so the bus begins to move, and you, being an independent mass, tend to remain at rest. Now you take a few steps back as you tend to maintain your position relative to the ground outside. You reach for a seat back or some part of the bus. Once you have a hold on some part of the bus, it supplies the force needed to give you the same motion as the bus, and you no longer find it necessary to step backward. You now have the same motion as the bus, and no forces are involved. At least until the bus goes around a curve, you now feel a tendency to move to the side of the bus. So the bus has changed its straight line motion. But you, again, being an independent mass, tend to move straight ahead. So the side of the seat forces you into the following the curve motion of the bus. The forces you feel when the bus starts moving or turning are a result of your tendency to remain at rest or follow a straight path until forces correct your motion so that it is the same as that of the bus. So that is now the concept of the Newton's first law of motion. So in short, okay, so in short, we can define that the first law of motion will, or that an object at rest will remain at rest unless it is put into motion by an unbalanced force. So that is the simply meaning of the Newton's first law of motion. And just like for our example a while ago. Now, let's proceed to the second law of motion. Okay, ano naman tong second law of motion ni Newton? Okay, so Newton had successfully used Galileo's ideas to describe the nature of motion. Newton's first law of motion explains that any object, once started in motion, will continue with a constant velocity in a straight line unless a force acts on the moving object. This law not only describes motion but establishes the role of a force as well. A change of motion is therefore evidence of the action of net force. So the association of forces and a change of motion is common in your everyday experience. You have felt forces on your back in an accelerating automobile, and you have felt another forces as the automobile turns or stops. You have also learned about gravitational forces that accelerate objects toward the surface of Earth. Unbalanced forces and acceleration are involved in any change of motion. Newton's second law of motion is a relationship between net force, acceleration, and mass that describes the cause of a change of motion. Now we have to consider the motion of you and a bicycle you are riding. Suppose you are riding your bicycle over level ground in a straight line at 10 miles per hour. Now, Newton's first law tells you that you will continue with a constant velocity in a straight line as long as no external unbalanced force acts on you and the bicycle. So the force that you are exerting on the pedals seems to equal some external force that moves you and the bicycle alone. More on this later. Now, the force exerted as you move along is needed to balance the resisting force of tire friction and air resistance. If these resisting forces were moved, you would not need to exert any force at all to continue moving at a constant velocity. So the net force is thus the force you are applying, minus the forces from tire friction and the air resistance. The net force is therefore zero when you move at a constant speed in a straight line. So if you now apply a greater force on the pedals, the extra force you apply is unbalanced by friction and air resistance. Hence, there will be a net force greater than zero and you will accelerate. You will accelerate during and only during the time that the net force is greater than zero. Take note this, okay? Take note this class that you will accelerate only, okay, if the net force is greater than zero. So likewise, you will slow down if you apply a force to the brakes, another kind of resisting friction. A third way to change your velocity is to apply a force on the handlebars, changing the direction of your velocity. Okay, so thus, an unbalanced forces on you and your bicycle produce an acceleration. Okay, ito na yung sinasabi nating acceleration. So, starting a bicycle from rest suggests a relationship between force and acceleration. You observe that the harder you push on the pedals, the greater your acceleration. Recall that when quantities increase or decrease together in the same ratio, okay, so they are said to be directly proportional. The acceleration is therefore directly proportional to the net force applied. Suppose that your bicycle has two seats, and you have a friend who will ride with you but not pedal. Suppose also that the addition of your friend on the bicycle will double the mass of the bike and riders. If you use the same net force as before, the bicycle will undergo a much smaller acceleration. In fact, with all the other factors equal, doubling the mass and applying the same extra force will produce an acceleration of only one half as much. So an even more massive friend would reduce the acceleration more. So now, this is the relationship of the two. Recall that when a relationship between two quantities shows that one quantity increases as another decreases. So in the same ratio, the quantities are said to be inversely proportional. Okay, so the acceleration of an object is therefore inversely proportional to its mass. So what do we mean by this? Okay, so we have the relationship between the acceleration, the force, and the mass. Now, it is said a while ago that your acceleration is directly proportional to the force and inversely proportional to our mass. So, what do we mean by this? So, if the acceleration increases, okay, so what will happen to the force? Okay, so the force will also increase. because the relationship of the acceleration and the force is directly proportional. Now, how about the acceleration and the mass? So, the relationship between the acceleration and the mass, they are inversely proportional. Okay, so paano sinabi natin, what do we mean by inversely proportional? Okay, so pag ang acceleration decrease, okay, si mass naman ay mag-i-increase. And vice versa. Pag si mass nag-decrease, si acceleration would increase. So, inversely proportional. Yan yung ibig sabihin ng Newton's second law of motion natin. Okay, so we can also rearrange this equation, okay, by finding or on the form in which it is most often expressed, which is F is equal to ma. The force is equal to the mass and the acceleration. So in the metric system, you can see that the units of a force will be the units for mass times acceleration. So the unit for mass is in kilogram and the acceleration is in meter per second squared. Therefore, the 1 kilogram 1 kilogram meter per second squared is also known as the 1 Newton. Okay? So, the same lang po sila. 1 Newton is equal to 1 kilogram meter per second squared. Okay, so that is the Newton's second law of motion. So Newton's second law of motion is the essential idea of his work on motion. So according to this law, there is always a relationship between the acceleration, your net force, and the mass of an object. Implicit in this statement are the three understandings that we are talking about the net force, meaning total external force acting on the object. That the motion statement is concerned with acceleration, not the velocity, and that the mass does not change unless specified. So the acceleration of an object depends on both the net force applied and the mass of the object, as you can see in our equation. Okay, nakadepende sa acceleration depending on the net force applied and how mass, or yung gaano siya kabigat, ganon. Okay, so now, the second law of motion now states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the mass of the object. Until now, equations were used to describe properties of matter such as density, velocity, and acceleration. So this is for example of an equation that is used to define a concept, specifically the concept of what is meant by a force. Since the concept is defined by specifying a measurement procedure, it is also an example of an operational definition. Just parang yung sinabi ko kanina. So you are told not only what a Newton of force is, but also how to go about measuring it. Notice that the Newton is defined in terms of mass measured in kilogram and acceleration measured in meter per second squared. So any other units must be converted to kilogram and meter per second before a problem can be solved for a Newton's of force. So, yung paulit-ulit na sinasabi ko sa inyo, if ang mass, ang given doon is in gram, so you must convert this into kilogram. Gaya din dun sa acceleration natin. Okay? So, take note and you must remember that our unit must be kilogram meter per second squared or 1 Newton. That is the unit of our force. Okay, so that is our second law of motion. Now we have a sample problem here. Okay, about the Newton's second law of motion. Sinabi natin kanina na hindi lang puro concept ang inaaral natin in the Newton's second law of motion. We have also this measuring, how to go about measuring on it. Okay, so our first example, what is the acceleration of a 20 kilogram cart if the net force on it is 40 Newton? Okay, so first we have to write all the given in the problem. So, ano yung given natin sa problem? We have acceleration, I mean the mass. We have the mass. Okay, so ano yung mass natin? Our mass is, okay, mass is equal to 20 kilogram. Next, we have a force. Okay, so our force is 40 Newton. Since nasa unit naman sila, nasa tamang unit naman sila, then we will proceed now to the computation. So the unknown, what we are looking for is the acceleration. Okay, what is our equation? We have the A is equal to F all over M. Since given ang force and the mass natin, all we need to do is to substitute all the given in our formula. So F is equal to 40 Newton divided by our mass, 20 kilogram. So 40 Newton divided by 20 kilogram, the answer is 2 meter per second squared. Oh, dali lang yan. As easy as eating money. Char. Okay, next. How about this one? Okay, so a 60 kilogram bicycle and rider accelerate at 0.5 meter per second squared. How much extra force was applied? Okay, so ang given natin, ano na ulit yung given natin? Okay, so given, mass is 60 kilogram. And the acceleration is 0.5 meter per second squared. What we are looking for is the force. Okay, so nasabi naman na kanina, okay, na-derive naman na natin si force. Paano kunin si force? We have F is equal to MA. Okay, nasa unit naman na sila. Nasa SI unit. So, all you need to do, again, is to substitute all the given in the problem. Okay, so mass is 60 kilogram. And the acceleration is 0.5 meter per second squared. So, what is the answer? We have 30 Newton. Okay, 30 kilogram meter per second squared or simply the 30 Newton. Okay, so yan naman na yung paano pa ang pag-compute ng acceleration force or in the relationship with our Newton's second law of motion. Now, we have proceed to weight and mass. Okay, so what is the meaning of weight? Is it the same concept as mass? Okay, so weight is a familiar concept to most people. And in everyday language, the word is often used as having the same meaning as mass. So in physics, however, there is a basic difference between weight and mass. Okay, and this difference is very important in Newton's explanation of motion and the causes of motion. So we now define mass as the property. Mass is defined as the property that determines how much an object resists a change in motion. Mass, okay, ulitin ko, ang mass natin is defined as the property that determines how much an object resists a change in its motion. So the greater the mass, the greater the inertia or resistance to change in motion. So consider, for example, that it is easier to push a small car into motion than to push a large truck into motion. Yes naman. Okay? So, mas madaling i-push natin yung maliit na bagay kesa yung malaki. Okay? So, the truck has more mass and therefore more inertia. So, Newton originally defined mass as the quantity of matter in an object. And this definition is intuitively appealing. However, Newton needed to measure inertia because of its obvious role in motion, and he redefined mass as a measure of inertia. You could use Newton's second law of motion to measure a mass by exerting a force on the mass and measuring the resulting acceleration. This is not very convenient, so masses are usually measured on a balance by comparing the force of gravity acting on a standard mass compared to the force of gravity acting on the unknown mass. So now, the force of gravity acting on a mass is the weight. So itong weight naman natin, this is the force of gravity. Okay. Take note na, guys, class, that ito may pagkakaiba ang weight and mass natin. Huwag kayong malito, okay? So weight is a force and has different units. Okay. Weight. Your weight is a force. Okay? Um, so it has a different units. So the unit of your weight is in Newton. Then mass is in kilogram. Since weight is a measure of the force of gravity acting on an object, okay, so the force can be calculated from Newton's second law of motion, which is F is equal to ma. Or we can measure weight, okay, so weight is equal to mass times the gravity, or simply W is equal to mg. Okay? So, remember class na ang weight and mass ay magkaiba. Okay? So, wag kayong malito. Now, since natakal na natin si weight and mass natin, okay, so we will proceed now to the Newton's third law of motion. So, your Newton's first law of motion states that an object retains its state of motion when the net force is zero, right? So, the second law state naman that what happens when the net force is not zero, describing how an object with a known mass moves when a given force is applied. So, the two laws give one aspect of the concept of a force. That is, if you observe that an object starts moving, speeds up, slows down, or changes its direction of travel, you can conclude that an unbalanced force is acting on the object. So thus, any change in the state of motion of an object is evidence that an unbalanced force has been applied. So Newton's third law of motion is also concerned with forces. First, we have to consider where a force comes from. A force is always produced by the interaction of two objects. Sometimes, we do not know what is producing forces, but we do know that they always come in pairs. Anytime a force is exerted, there is always a match and opposite force that occurs at the same time. So for example, if you push on the wall pushes back with an equal and opposite force. So the two forces are opposite and balanced. And you know this because of, okay, so you know this because of the formula F is equal to ma. And neither you nor the wall accelerated. If the acceleration is zero, then you know from F is equal to m that the net force is zero. Okay? So kapag zero na si acceleration natin, then the net force naman natin is zero. Note also that the two forces between two different objects, you and the wall. So the Newton's third law always describes what happens between two different objects. So to simplify the many interactions that occur on Earth, consider a spacecraft in space. So according to the Newton's second law of motion, a force must be applied to change the state of motion of the spacecraft. What is a possible source of such a force? Now perhaps an astronaut pushes on the spacecraft for 1 second. The spacecraft would accelerate during the application of the force, then move away from the original position at some constant velocity. So the astronaut would also move away from the original position, but in the opposite direction. So a single force does not exist by itself. There is always a match and opposite force that occurs at the same time. Thus, the astronaut exerted a momentary force on the spacecraft, but the spacecraft evidently exerted a momentary force back on the astronaut as well. for the astronaut move away from the original position in the opposite direction. So Newton did not have astronauts and spacecraft to think about, but this is the kind of reasoning he did when he concluded that forces always occur in matched pairs that are equal and opposite. So now therefore, our third law of motion states that whenever two objects interact, the force exerted on one object is equal in size and opposite in direction to the force exerted on the other object. So the third law of motion states that forces always occur in match pairs that act in opposite direction and on two different bodies. So we can now express this law as the symbol that F, your force, is A due to B is equal to F B due to A. Now, anong ibig sabihin nito? So, where the force on the astronaut, for example, would be A due to B, and the force, okay? So, this is the force of the astronaut. And this is the force of the satellite, okay? So, the satellite would be B due to A. Sometimes, the third law of motion is expressed as follows. So, for every action, there is an equal and opposite reaction. But this can be misleading. Neither force is the cause of the other. The forces are at every instant the cause of each other, and they appear and disappear at the same time. If you are going to describe the force exerted on a satellite by an astronaut, then you must realize that there is a simultaneous force exerted on the astronaut by the satellite. So the force or the astronaut on satellite and the satellite on astronaut are equal in magnitude and opposite in direction. Parang yung example natin kanina na yung wall and yourself. Pag pinush mo yung wall, then you have then zero acceleration. Okay, now perhaps it would be more common to move a satellite with a small rocket. So a satellite is maneuvered in space by firing a rocket in the direction opposite to the direction someone wants to move the satellite. So exhaust gases or the compressed gases are accelerated in one direction and exert an equal but opposite force on the satellite that accelerates it in the opposite direction. So this is another example of the third law. Okay, so another example. So consider how the pairs of forces work on Earth's surface. Okay, so example. You walk by pushing your feet against the ground. Of course, you could not do this if it were not for friction. You would slide as on slippery ice without friction. But since friction does exist, you exert a backward horizontal force on the ground. And as the third law explains, the ground exerts an equal and opposite force on you. You accelerate forward from the net force as explained by the second law. If Earth had the same mass as you, however, it would accelerate backward at the same rate that you were accelerated forward. Earth is much more massive than you. However, so any acceleration of Earth is a vanishingly small amount. The overall effect is that you are accelerated forward by the force the ground exerts on you. Return now to the example of a riding bicycle that was discussed previously. So what is the source of the external force that accelerates you and the bike? Pushing against the pedals is not external to you and the bike, so that force will not accelerate you and the bicycle forward. So this force is transmitted through the bike mechanism to the rear tire, which pushes against the ground. It is the ground exerting an equal and opposite force against the system of you and the bike that accelerates you forward. So you must consider the forces that act on the system of the bike and you before you can apply this equation. F is equal to ma. Now, the only forces that will affect the forward motion of the bike system are the force of the ground pushing it forward and the frictional forces that oppose the forward motion. So this example, this scenario is another example of the third law of motion. So, now, ang may computation lang natin is the second law of motion. And the rest is the pure concept naman na siya. So, those are, ayan lang yung simple explanation of the three laws of motion natin. So, for the next meeting, we will discuss again the impulse and momentum. So, thank you everyone and goodbye.